All right, we're going to do three things today. We're going to determine if two matrices are inverses of each other. Then we're going to find something called a determinant. And we're going to use the determinant to help me find an inverse of a matrix. All the matrices we're dealing with today are square matrices. So what does that mean? They have the same number of rows and columns.
Yes.
So when you're dealing with inverses, you're always going to be dealing with a square matrix. We're going to be dealing with 2 by 2s and 3 by 3s today. So first thing we're going to do is we're going to be given two matrices, and we want to determine whether or not these matrices are inverses of each other.
Okay.
Alright, so our A matrix is 12, negative 7, negative 5, 3. Our B matrix is 3, 7, 5, and 12. Alright, so I want to determine if these two things are inverses of each other. To do that, we're going to multiply them together. The result tells me whether or not they are inverses. So I can look at the result and determine it. So, before we do that, let's remind ourselves what a multiplicative inverse is. Let's say I have the number 2/3. What is the multiplicative inverse of 2/3?
Negative 3 over 2.
Nope.
Oh, I think it's just
3 halves. What do I get when I multiply these two together?
1.
I get 1. 1 is considered the multiplicative identity.
Oh yeah, I remember that.
Okay.
So, what we want to get when we multiply two matrices together is the matrix identity. So we're going to multiply them, and then we'll figure out what the matrix identity is.
Is it rows turning into columns?
Say it again.
Is it rows that the rows turn into columns and one of them's negative? Okay. So they're
Alright, so as a refresher, it should be obvious that we can multiply these two together since they're the same type of matrix. Right. Well, since it's square. Alright? But remind me, what do I need to look at to determine if matrices can be multiplied together?
Yeah, I think it is.
Now the order. So this is a 2 by 2. That's a 2 by 2. These two match, so I can multiply. So that means that's what I end up with. So A times B is going to be a 2 by 2 matrix. Remind me what we need to do to multiply matrices together.
Whoa. In your first matrix, 12 and negative 7 is your first set of numbers. I like to circle it. And then on part B, I circle 3 and 5. I multiply 12 by 3.
Alright, what I'm looking for is row times column. So 12 times 3 is 36. Negative 7 times 5 is negative
Because I want to
35.
make an example.
Hush. And I'm going to do row 1 again times column 2 this time. So it's going to give me 84 minus 84. 12 times 7 is 84. Negative 7 times 12 is negative 84. I move to row 2. Row 2 times column 1. That's negative 15 plus 15. Then I need row 2 times column 2.
Negative 35
So negative 35
plus 36.
plus 36. So the resulting matrix is 1, 0, 0, 1. 1, 0, 0, 1 is the identity matrix, the 2 by 2 identity matrix. So an identity matrix is going to be the diagonal is only 1s and everything else is a 0. That's an identity matrix. So to determine if two matrices are inverses, multiply them, you get the identity matrix. The answer is yes, they are inverses. If you do not get the identity matrix, the answer is no.
And it's a thing. You said a thing where you said what the identity matrix would be. Where the zero, if the diagonals are 1?
Diagonals are 1.
Okay.
Starting in the upper left, everything needs to be a 1 there, and then everything else needs to be a 0. So if I'm looking at a 3 by 3, I need a 1, a 1, and a 1, and then everything else has to be a 0. That's the 3 by 3 identity matrix.
Okay, that makes sense. I missed what you said.
Which diagonal is What if it's a 3 by 2?
Square.
Okay.
Must be square. So that's the first thing. Determine if matrices are inverses. Multiply them. If you get the identity matrix, the answer is yes. If you don't, the answer is no.
So you're
Yes or no. The last are these two inverses of each other. You multiply and then you say yes or no. All right. So that's number 1. Number 2, we want to find something called the determinant.
No, bum bum.
Positivity over there.
Self-compromise.
Respect.
All right. -8, 2, -6, 3 is the matrix I'm dealing with. I want to find the determinant. To find the determinant, I'm going to start in the upper left and multiply in the bottom right. So -8 times 3 gives me
-24.
-24. Then I have to do the reverse of that. I start on the bottom left, multiply to the top right. So that gives me -12. Then I'm going to subtract. I always subtract on the bottom. So it's going to be -24 minus the -12. So we end up with -12. So my determinant is -12. Okay, the determinant is going to be used for a couple things. It's going to help us with our third goal today in finding the inverse. It's also going to help us with Kramer's rule, which is an alternate method to what we were doing the last 2 days to solve a similar equation.
Well, we're gonna have to use our previous method, like on the test.
You have to be able to do both.
Oh, that's unfortunate.
I figured it out.
All right, so another one.
All I see is numbers. We're math. And variables too. Speak to
There are 2, 8, 4, and 16. I want to find the determinant of this matrix. So I'm going to do 2 times 16 gives me 32. I'm going to do 4 times 8 also gives me 32. You always do the subtraction on the bottom. So we end up with 0. If you get a determinant that is 0, that means that matrix does not have an inverse. If the determinant of a square matrix is 0, that matrix does not have an inverse.
So put no inverse.
No inverse.
Lucky.
If it's any number but 0, it has an inverse. All right, let's look at a 3 by 3. Finding the determinant of a 3 by 3.
Oh. You just do the same thing.
So do you, was 0 your answer on that one?
Yes.
Is this another one of the same
This is-
determinant ones?
By still finding the determinant, now we're looking at a 3 by 3.
Okay.
3 by 3 is a little bit more involved. It's still not bad. To get started on a 3 by 3, I need to take the first 2 columns and repeat them to the right. Take the first two columns and repeat them to the right. And just like on a 2 by 2, I want to start in the upper left and multiply down diagonally. So -1, 6, and 8 gives me -48. I've got to move over to the next number. -1, 4, and 2
Oh, wow.
gives me -8.
Interesting.
Wait, this is mad.
Interesting.
And then one more time, -3, 3, and 1,
How about I circle?
-9. And you need to put all those together. So -48 and -8 is -56. With another -9 makes it. So my bottom number is -65.
Since you start at the top with all of them whenever you're going down, you don't have to subtract anything. You just put the numbers together like you're adding.
Correct.
Okay.
Okay, then we have to go to the bottom left and multiply up.
Oh, wow.
So 2 times 6 is 12, 12 times -3, -36. I move over. 1 times 4 is 4, times -1 is -4.
And then 8, 3, and
And 8, 3, and -1, -24. -36 and -4 is -40.
-64.
So we end up with -64 on the top. And again, where do we do the subtraction? On the bottom. So -65 minus -64. -1 is my determinant. What does that tell me about this 3 by 3 matrix? It does have an inverse.
So you only do if it's on the bottom, the very last.
Alright. Do you need to see another 3 by 3 determinant, or are we good to go?
No, we're
I'd like to see another one just for
Nope.
the homework though. I heard you say
Yeah, what is it? What does it go
It's not being used for a reason.
Like, what is the like maximum like 3 times by 3? Like, what does it go up to?
All we're dealing with is 2 by 2 and 3 by 3.
Let's not worry about the
Does
times.
it go
Could you?
bigger than that though? So you would have like get like
Give us the hardest one.
I don't know. I don't know if I've ever seen it or if I remember anything past 3 by 3.
They're doing the top one.
Alright, so we've done number 1. Determinant matrices are inverses. We've done number 2. We found the determinant. Now we want to find the inverse of a matrix. We can find the inverse of a 2 by 2 by hand. The inverse of a 3 by 3 we can't do by hand. It's very involved, so we're going to use our calculator. So we're going to do a couple of 2 by 2s, and then we're going to do a 3 by 3 using our calculator.
I have to go to
Guess what? Mine.
Alright, 6, -5, 3, -2. What do you think the first thing is we need to do? Find the determinant. So 6 and -2 gives me -12. 3 and -5 gives me -15. -12 minus -15 gives me a determinant of 3, which tells me there is an inverse. Now we're getting ready to find out why, if the determinant is 0, I do not have an inverse. Because once you find that determinant, you have to put it underneath 1. That right there tells you why, that if your determinant is 0, you will not have an inverse. Because at that point, I would do 1 divided by 0, which is not good. Undefined. So that's why if your determinant is 0, there is no inverse. Alright, then we have to do a little bit of mixing with our matrix. We need to switch the upper left with the lower right. Those two numbers need to switch spots. So I'm going to have -2 here. I'm going to have 6 there. On the other two, they don't switch locations, but they do switch signs. So the 3 is going to turn into -3. The -5 is going to turn into 5.
The beginning of that.
So, are people just doing random math?
-7, -5.
It seems kind of cool.
Or maybe
I don't know if I'll just remember this.
All right. Then the next thing I need to do is multiply the 1/3 through everything. What is that called?
Distribution.
Yeah, but what is it called? What we learned it was called the other day when I take one number and distribute it through a matrix. Starts with an S. Scalar multiplication.
Look at you.
Yeah. How about result, Blake?
That's what matters.
Listen,
Right there.
not wrong.
So if I multiply the 1/3 through, that's what I get. So if I'm going to call this first one A, what can I call this inverse that I found?
A
A to the -1. So the first one's A, the second one is A to the -1. How can I verify that this is in fact the inverse of the matrix I started with? I can multiply. You do not have to do that, but I'm going to do it so that you will see that we did it correctly. So I'm going to multiply these two together, and I should get the identity matrix if we did it correct. So I should end up with a 2 by 2. All right, row 1, column 1, -2/3 times 6. -4. 5/3 times, well, that's not the right one, is it? No. 5/3 times 3.
-10/3. Third of 2. Okay, you know what?
5. The 3's canceled.
Wait. Oh, so
I did it with
I was
the
looking
negative
at
two,
wrong
okay.
column. It's like
That was my bad.
All right, row 1, column 2, -2/3 times -5.
That one's
yeah.
Positive 10/3. 5/3 times -2.
-10/3.
Okay, how do we look so far? Are we getting what we want?
Yeah.
Yes, I've got a 1 and I've got a 0, so far so good. All right, -1 times 6, -6, 2 times 3, +6, so we're still looking good.
Now we need a 1.
-1 times 5 is 5, 2 times -2, -4. So as you see, we get a 1, a 0, a 0, and a 1, which is the identity matrix, so that tells us that we found the inverse correctly.
To practice this, we should have played matrices bingo that way.
Oh, that was fun.
So,
I thought that was a good idea.
find the determinant. Put the determinant underneath 1. Switch upper left and lower right. Change the signs of the other two. Distribute your coefficient. And you have found the inverse. Questions on that? All right, now get your calculator out so we can do a 3 by 3.
Yeah. I can't much
Don't need to talk. So 3, 1, -2, 8, -5, 2, -4, 3, -1. So we're going to use our calculator to do everything.
That's nice, actually. Plus, I want What is it, can I have a button for this?
Whoa. So we're going to add a calculator. The button directly to the right of 9. Click that button. Then if you notice in the middle, we have a matrix. So we can click on that. Then it wants to know what type of matrix do we want. We want a 3 by 3, so we just click OK. Now I go through and fill the matrix out.
Question. Does this work for all of our matrices?
It does.
No cheating.
You're going to have to do the 2 by 2 by hand. You can,
Yeah.
however, check it with your calculator if you'd like.
Will we get that option on the test?
On the test, no.
Nice try, nice try.
Good thought, good thought.
Well, the
Large
two
ones.
put it in.
You will have a calculator for finding a 3 by 3 inverse, yeah.
Okay.
Make sure you put the negative
Yeah,
instead
not
of the
the
minus.
Yes, I was thinking that. Mr. Madison.
What are you doing?
Not said you.
He does.
Once you get it filled out, move to the right. Any ideas on what we're going to do to turn this into an inverse?
Put it.
Raise it to the -1 power. Good. So I hit the caret over here on the left. That's a caret. Gives me my exponent, and all I've got to do is put -1 in there. Press enter. There's my inverse matrix.
Why is it called a carrot?
Oh, that's so cool.
It's just what it's called.
I love
It
it.
kind of looks like a carrot.
What happens if
So
I don't see no.
that is determining if matrices are inverses, finding the determinant, and finding the inverse of a matrix.
Well, wait, so
I would not do
we
that.
don't have to check this?
Nope.
It's a calculator.
But you can multiply it.
I know.
You're telling me you wanna put yourself through all that, what is wrong with you?
Here.
Don't ask for
I'll show you.
Here's a second one.
Oh, sweet.
I'm going to arrow up,
Rachel,
I'm gonna
why?
grab that. then I'm going to delete the exponent.
Good.
Then I'm going to go times. I'm going to arrow up. I'm going to grab the inverse. And when I press enter, what should I get?
You should get
We get
two.
the line.
1, 2, 0.
I should get the identity matrix.
Yeah, it's magic.
That's cool.
Y'all see
man.
that? See what that calculator just did, Rachel?
Wait.
Hey.
Do you-
Magic.